Good afternoon, and thanks for joining us for our webinar on website hosting in the cloud. Today's presenter will be Leo Jadnowski, our Senior Solutions Architect here at AWS. During the webinar, feel free to submit any questions in the Q&A panel to the right of the screen. And now I'll pass it over to Leo to get started.
Hi everyone, my name is Leo. I'm a solutions architect here at Amazon Web Services, and I'm gonna go through a live demo and talk to you about hosting websites in the cloud. So AWS consists of a bunch of different services, going from our global infrastructure networking to our core foundational services that involve compute, storage, and database, to higher level application services that you then use to build your applications for the cloud, and to administration and deployment services allow you to administer your AWS account and deploy your code onto your AWS resources. So let's talk about the services that are most central when you're hosting a website on AWS. So in terms of compute, our core service is called EC2, or the Elastic Compute Cloud, and this is our virtual servers in the cloud service. There are over 30 types of instances, which we'll talk about in a second. Instances are just different sizes of virtual servers, and there's ones that are optimized for memory, ones that are optimized for compute, ones that are optimized for I/O. So you just pick whichever instance type or types that you need for your specific workload or use case. You can launch one or hundreds or thousands of instances if you need to in minutes or seconds. So you can scale your capacity up and down as your requirements change. So for example, if you've got a website that has spiky workloads or spiky traffic, so by default you have a certain level of traffic, then you send out some sort of email, or you have a class registration that happens, and then you get a lot more traffic. You can, on AWS, scale horizontally as you need to, and then scale back down when your traffic slows down. You only pay for what you actually use, so the default payment model is called on demand. You're paying by the hour for instances, so running one instance for 10 hours or running 10 instances for 1 hour costs the same exact thing. In terms of operating systems, you can choose different distributions of Linux. So we have our own distribution called Amazon Linux. There's a bunch of third-party distributions on there, such as Ubuntu and Red Hat and CentOS. So you can pick whichever distribution suits your needs. In terms of Windows, you can run a Windows Server 2008, 2012, and the Windows licensing is part of the hourly cost. Now, you can also deploy across regions and availability zones. So AWS has currently 10 regions around the world. There are 3 regions in the US, one on the East Coast, 2 on the West Coast. Those regions, you can each think of them as completely separate clouds. Then within those regions, there are availability zones. Availability zones are like different data centers within each region. So they have redundant ISPs and power feeds, and they're built to be on different floodplains, but it's easy to distribute your workload among multiple availability zones within one region. Now, you also can do something called VPC, which is the Virtual Private Cloud. This is your own address space within AWS, so you can break that address space up into subnets. You can have private or public subnets, so it's really good for security and for controlling your network. Now, in terms of the instance types, let's just quickly go over what instance types there are. So if you don't have an application that specifically needs to be compute optimized or memory optimized, the general purpose instances are a really good place to start. That's the M3 family of instances. Now, there's also compute optimized. So compute optimized instances have a higher ratio of virtual CPUs to memory. So they're good for things like web servers or other compute-intensive tasks. Then there's memory optimized. So the R3 family of instances is memory optimized. These have a higher ratio of memory to CPU. So these are great for things like relational databases that are memory intensive. We also have a family of storage optimized instances. These are I2s. And these instances have large amounts of local storage available to them. Most of the instance types have SSDs on them, so you can achieve really high I/O rates. And this is great for for things like NoSQL databases where you're going to have enough redundancy to be able to use our instance storage. But so things like Mongo or Cassandra, this is a great use case for. And then we have GPU instances. So GPU instances are the instance types that you would use for GPU intensive workloads. They have built-in NVIDIA Kepler GPU chips inside of them. Those are the GPU instances. Lastly, we have the cost optimized instances. This is the T2 micro family of or the T2 family of instances, and these are great for if you're just experimenting and you want to get started on AWS and you wanna be as efficient as possible in terms of your budget. So the basic building block of an EC2 instance is an Amazon Machine Image or an AMI. AMIs are basically a template of what you're actually launching. So an AMI is one or more EBS volumes, or you could have S3 backed AMIs. And these AMIs, when you launch an instance, you have to pick which AMI you use. So you can use one of the AMIs that's provided on our AMI marketplace, or that we have our third-party partners provide, or that we provide, such as CentOS or Amazon Linux or Windows AMIs out there. Or you can take one of those AMIs and then make your own. AMIs can be public, so the ones that you can launch we provide, that our partners provide, those are public, or they can be private. So the ones that you create are private, and you have the option of then sharing those images with other accounts. This is great for creating gold images for your infrastructure. So if you've got some sort of institutional security requirements, you can take those images and standardize them and apply all of your software or whatever your requirements are to those images, and then have people in your organization launch those specific instance types. You can also copy images between regions, so that's great for DR. Now, the persistent storage that you get on EC2, that's called EBS. So EBS stands for Elastic Block Storage. These are volumes that live inside each availability zone. They can range from 1 gigabyte to 1 terabyte in size. There are 3 different types of EBS volumes. There's the magnetic EBS, which just uses magnetic storage. There's general purpose SSD, which gives you SSD storage. And then there's provisioned IOPS. So provisioned IOPS is also SSD based, but you can guarantee your IOP performance with provisioned IOPS. So you can get up to 4,000 IOPS per volume with provisioned IOPS. You can detach or reattach your EBS volumes from your instances. You can snapshot those volumes, and once you snapshot them, the snapshots go into our S3 or simple storage service. So these are great building blocks for specifically for web hosting. Next is auto scaling. So auto scaling is an API that's part of EC2 that you can use to horizontally scale your servers up or down. So you can either use this to scale manually, so you can say, I want to go from 2 instances to 100 instances right now, or you can scale by schedule. So if you know you're going to get traffic at a certain time, you can say, at 8 a.m. tomorrow, launch 100 instances, or you can have it automatically scale up and down. So you can define conditions based on our CloudWatch metric service. So you can say, if across all of my web servers, the average CPU usage is greater than 75% for 10 minutes, launch 10 more instances. And then if it's smaller than 40% for 10 minutes, kill off one of the instances. So you can actually scale up and down automatically and have elastic capacity as you need to. Now, this is great for applications such as websites that tend to have variable amounts of usage. You can set minimum and maximum scaling policies so you don't have overrunning costs. Sorry, one second. Let me get back to my PowerPoint here. There we go. And so by setting a maximum, you can make sure you never scale above a certain amount of servers. Now, you can also use this for fault tolerance. So you can have an auto-scaling group of 1. So if you have one server that does a specific task, it doesn't necessarily need to scale up or down, but you can never go below 0 servers for that specific task. You can have an auto-scaling group that is at 0 or at 1. Now, the next building block here is called elastic load balancing. So ELBs are or Amazon managed load balancers. So you can provision one in minutes. They live inside of a region, so they support multiple availability zones out of the block. They can support load balancing ports 25, 80, 443, and any port greater than 1024 for TCP traffic. They support the proxy protocol and SSL termination, so you can terminate your SSL traffic at the ELBs. They support TCP and HTTP health checks, so they can determine whether to send traffic to underlying instances or not, based on if the health checks pass. And ELB is a scalable service in the background, so without your intervention, it grows or shrinks based on how much resources that given ELB is using. It also integrates with auto scaling. So when you scale up or down with auto scaling, you can have your instances bind themselves to an Elastic load balancer automatically. ELBs also work inside the VPC, so you can have an external ELB for a public website or an internal ELB for an internal service. Lastly, ELBs give you a single DNS CNAME, so when you're referencing them, you can always use that CNAME and it never changes. And that way, even if the ELB in the background scales up or down, you don't have to change anything on your end. So lastly, let's talk about our database service. So we have a service called the Relational Database Service, and it is a managed relational database service. So you can run databases of different engines, which are MySQL, Postgres, Oracle, or Microsoft SQL on it. It runs on instances, so you can pick which instance size you want. It handles a lot of tasks for you that you would normally have to handle, such as backups and patching. So it backs up to S3, and you can use those backups to create new RDS instances. It also supports multi-AZ. So with a selection of a checkbox, you can make your database redundant across multiple availability zones and have auto failover that you don't have to initiate it. It's just managed for you. In terms of licensing for Postgres and MySQL, RDS, Postgres and MySQL are open source, so you don't have to pay anything for the license. For Oracle and Microsoft SQL, you can either bring your own license or have the license included as part of the hourly charge. Lastly, if you have an application that needs to be live in multiple regions, then for MySQL, we have the option of a cross-region read replica. So you can have a read replica that lives outside of the region, in another region, and you can promote it to master in case you have to fail over to that region. And in terms of read replicas, you can also provision read replicas within the same region automatically in some of these engines here. So now that you've got your compute level and your database tier, how do you actually deploy code to AWS, right? So the first option you have is CloudFormation. CloudFormation defines a stack of AWS resources. So think of it as your infrastructure as code, and those are defined in a single JSON file. So you define your resources that you need, so your ELBs, your VPCs, your security groups, your instances, and then you take those and you write a file with those, and you can redeploy the same infrastructure over and over again with that file. So the nice thing about that is that if you need to recreate a test environment of your production environment, you can just use this file and deploy it. The other thing is this allows you to put your infrastructure in version management because it's based off of a text file, so you can easily just keep track of the changes in your infrastructure just as you do in your code. Now, I want to demo this for you. The next thing we're going to talk about is called Elastic Beanstalk. So let's say you're a developer and you don't want to have to worry about setting up ELBs or your Apache web servers or handling these low-level details of setting up a website. Well, what you can use is Elastic Beanstalk. You give Elastic Beanstalk your application, so it could be a Java, .NET, PHP, Node.js, Ruby, Python, or a Docker container. And it then takes your application, it deploys the EC2 instances, sets up an auto-scaling group, sets up an ELB, and sets up a database. And then after it's done, you have full control over the resources that are spun up. You can use it to have rolling upgrades between different versions of your code. And it also allows you to easily switch over between your two versions of your code, right? the other thing that's really nice about this is Elastic Beanstalk is a free service. You only pay for the actual underlying services or resources that it spins up. Now, another similar service is called AWS OpsWorks. So OpsWorks is a little bit more, you can have a little bit more control over what it does. So it's a DevOps service. So you break your application up into layers. So you can have your web server layer and your load balancer layer and your database layer. And you control what goes in each layer by putting in chef recipes into the layers. So the chef recipes, Chef is a configuration management system that's pretty common out there. So there's a lot of websites out there that can give you pre-built chef recipes that you can use. Additionally, this supports lifecycle events, so you can use those lifecycle events to do things like software updates. So let's talk about how to architect for high availability, which is important for a lot of websites. So the first thing that you want to do is you want to use multiple availability zones. Running an instance or running two instances in one availability zone costs the same thing as running two instances in two availability zones. So you should always use multiple availability zones. You should, if you're using RDS, the way to scale RDS is to spin up read replicas for RDS and use multi-ISI to make it not a single point of failure. Now, the read replicas allowed you to break up your reads from your writes in your application. And a lot of applications are really read heavy, so it allows you to scale your reads. When you need to scale your writes, you're going to want to vertically scale your RDS instance. So you're going to want to take the master instance and just upsize it. And when you can't upsize it anymore, you're going to want to shard your data across multiple masters. Then you want to use auto-scaling groups for your web and application servers. So your web and application servers should dynamically grow up and down depending on your traffic. And then you want to put an ELB in front of your web servers so that ELB will distribute traffic equally among however many web servers you have. So that's how you scale for high availability. Now, the last thing I'm going to talk about before the demo is if you don't want to use OpsWorks, if you want to, handle your management yourself and your configuration management and your deployment, there's a lot of options out there. So common configuration management systems and configuration management systems are systems that make sure that your instances are in the desired state. So what that means is they will make sure that certain packages are installed, that your application's installed, that it's the right version of it. So the common systems I see out there are Puppet, Chef, SaltStack. They're all open source. You can run them all on AWS. Then there's deployment frameworks. So deployment frameworks allow you to actually deploy your code onto your instances. So we talked about Elastic Beanstalk and OpsWorks. Some other common ones out there are Ansible, Fabric, which is written in Python, and Capistrano, which is pretty similar to Fabric but written in Ruby. Lastly, we talked about CloudFormation, and CloudFormation is infrastructure management. So it doesn't just manage your instances, it also actually manages your actual infrastructure as well. So whatever resources you have spun up outside of your instances in EC2. So now let's do a live demo of how to set up Drupal on AWS, both manually and through Elastic Beanstalk. So I've got my AWS account here, and first let's take a look at how to do this manually, just to show you how much easier it is to do through Elastic Beanstalk. So I've got an instance that I've spun up here. It's just a standard Amazon Linux instance. And so I'm going to SSH into it. So I'm going to SSH into my instance here. All right, so now I'm in my instance. This instance has just been spun up a few minutes ago. And so the first thing I'm going to have to do is I'm going to have to install the software that I need to run Drupal. So I'm going to become the root user and install Apache. I'm going to install PHP. I'm going to install the PHP add-on for MySQL. I'm going to install the MySQL client, the MySQL server, and that should be all. Oh, and I'm going to need to install some extensions for PHP. So these are all installing. So then I'm going to have to make sure that my web server starts on boot. I'm going to have to make sure that my MySQL server starts on boot. I might have to actually start my MySQL server. And so now my SQL server has started. I'm going to have to secure my installation of it. I'm going to run through this routine here. It's going to ask me for my root password. Since I just installed it, there is no root password. I definitely want to set a root password, so I'm going to set a root password here. And I'm going to remove these anonymous users MySQL creates by default. And I'm going to disable root login remotely because I shouldn't need to do that. And then there's a test database in there too. So that's all set. So now my MySQL is set. So I should be able to log into MySQL. So let's just test that. Yep, so now I'm in MySQL. So now I'm going to download the code for Drupal. I'm going to go over to the Drupal website over here. I'm going to go download the code. I'm going to take this tarball here. It's downloading Drupal. Now I'm going to extract Drupal in another directory. All right. Now I'm going to copy, or I'm actually going to move my old HTML directory out of the way. I'm going to move Drupal in its place. Then I'm going to have to change permissions on here so that the web server owns all the files on my Drupal. And then I'm going to start my web server, and hopefully it will work. All right, so now I've started my web server, so I should be able to just go to my instance now in a web browser. Let's try that. All right. So now we've got the Drupal install page here. I'm just going to change the default options. Oh, looks like I'm missing something. So I'm going to need to install some add-ons here. For 1 second. All right. And I'm going to restart my web server. I'm going to hit refresh on here. So I just need one more thing here. We're going to figure out which extension I need here. Okay, so that's PHP XML. Okay, so I'm going to install that one. All right. I'm going to hit refresh on here one more time. All right, so now I've got all my prerequisites. So I'm going to have to create a database. So let me do that. All right, so now I've created a database. And user, now you should never use a root user like this, but for the purposes of time in this demo, I'm going to do that. You should create a special user just for Drupal. All right, I don't want to save this password. And so now Drupal is installing. Now I'm going to just go through the last screen here and set my settings here. Country. Oh, my passwords do not match. All right, so now I've installed Drupal, and I've got a fully working Drupal site here. Now, as you can see, there's a lot of steps involved in this. It's not too hard if you've done this before, but all I've done here is I've installed Drupal on one instance that has the database on the same instance. So it's not really scalable. If this Drupal site were to start picking up traffic, I'd have to either upsize my instance. But what I really want to do is I'd have to start breaking out the database, use RDS for the database, use an auto scaling group for my web servers, and so you can do all that. But the nice thing is that Elastic Beanstalk does it for you. So let me show you how that works. So I've got a few Drupal demo environments already set up here, but let me show you what it would look like to actually start up a new one of these. So Elastic Beanstalk has this concept of applications. So an application is a different app, and then within that application, you can have different environments. So an environment is like a different version of your application. And if you create a new environment within the same application, you can swap which one's in production, which is really nice. So I'm going to launch a new environment here. And I'm going to select what it is. You can do web servers or workers. Then you can pick a platform. So as I mentioned, these are the supported platforms. So I'm going to pick PHP. And you can either have it on a single instance, which is what I just set up manually, or you can have it so it's load balanced and auto scaled. So I've already previously uploaded my Drupal, which is the same just zip file that I used before. I'm going to choose that. And I'm just going to give a name to this environment. It's going to be my third environment here. I check if the DNS name is available, which it is. And I'm going to choose whether I want to create an RDS instance or not. So I probably do. So I'm gonna choose RDS, and I want to create this inside my VPC. You should always use a virtual private cloud. So now I'm going to pick which instance size do I want. So I want something that's CPU intensive, so I'm going to pick a C3 large, and then I'm going to pick one of my key pairs, and then I'm going to put my email address, so it sends me email about what's going on in this environment. So it'll send me an email if it's healthy or if it's not, and I'm going to set what health check I want. So I want it to work on index.php. I'm going to enable rolling updates, so that updates one instance at a time if I have multiple instances in an auto scaling group. And I'm going to pick tags for my environment. So this is going to be, let's say, environment, and it's going to be testing. So you want to tag your instances so that you know what they are later on. And then I'm going to pick what I want to do for my database. So I want a, let's say, an M3 medium for my database. I want it to be 10 gigabytes. I want to give it a username and a password. I'm just going to pick one here. And I'm going to pick whether I wanted to, if I delete this database, do I want it to create a snapshot before it gets deleted or just get deleted? So for the purposes of this test, I just want it to be deleted. And then this is really important. I'm going to pick whether I want this to be in multiple availability zones or a single availability zone. I don't want this setup to have a single point of failure, so I want multiple availability zones. So then, since it's in a VPC, I have to pick which subnets this lives in. So I have public subnets and private subnets inside my VPC. I want the database to be in the private subnet, so I'm going to choose my private subnet here. And I want my EC2 instances and my ELB to be in my public subnet, so I'm going to choose that. All right, and then I'm going to leave the security group setting as default, and this is an external app, so I'm going to want my ELB to be external. Now it's just going to ask me to review my settings, which I'm okay with. And so now, as soon as it validates my settings, it's going to launch my environment. So while that's going to take a few minutes to launch, So while that's launching, let's see what this actually looks like once it's already launched. So I have one of my previous environments here. So this I launched earlier today. So it's running the same exact code. As you can see, once it's launched, you can configure a bunch of things here. You can configure the auto scaling policy, so configure how many instances you want. So right now it's a maximum of 4. You can configure what availability zones they live in, so your application can be multi-AZ. You can configure how do you want it to actually scale up and down. So what's the trigger for scaling up or scaling down, right? You can do CPU utilization, network, disk, latency, all kinds of stuff here. You can reconfigure what instance sizes you're using. You can have notifications. You can configure your software updates. Then you can configure your database, which is here's my Rds instance, and how your load balancer is set up on here. Now you can also get your logs on here. So if I click this button, what it's going to do is it's going to pull logs from my instances and show them to me here. So I can see the things like the web access logs, the system logs. So if something's not working properly, I can see what's going on. Then I can also see monitoring, so I can see, all kinds of information on my actual application, how much network it's using, how much CPU it's using. And then I can set alarms, so I can get, if some alarm gets tripped, I can get email notifications on that. And then I can see events. So here I clicked on pull logs and it successfully completed that. So I can see what events have happened to my environment. Here are my actual logs. So I can see a log file here for my instance if I want. These are the actual system logs. So after all this, you can actually go into your application here, and this is my Drupal that installed with Elastic Beanstalk. So unlike the Drupal that I manually installed earlier, this Drupal is using an auto-scaling group and an Elastic Load Balancer and an Rds Instance, so it's far more scalable out of the box. So that's my demo. So I think now we're going to open it up for some questions.
So before we get to the questions, a quick announcement. The AWS Education and Government team is kicking off a 2014 website hosting initiative. This is a great opportunity for universities, colleges, state and local governments to work side by side with AWS engineers and professional service staff on deploying one of your websites onto AWS. Inclusion is open to organizations with approvals and available resources. AWS will help you select a website, perform architecture reviews, help create new AWS architectures for your site, and you'll exit the engagement with a migration plan and a functional staging environment already running on AWS. We'll be following up with all attendees after the webinar, so just simply reply to that email and let your account manager know that you're interested, and we'll help you get started. So we're flashing some poll questions now. So we'll take a minute or two to flash these across the screen, and then we'll open it up to Q&A. Remember, we have a Q&A panel there where you can submit a question, and we'll get to those questions in just a minute or two.
All right, so we're gonna start taking questions. So if you have questions, put them in the chat. All right, so we got a question here that says, great overview on dynamic websites. Is there a way to host a static website? So a great way to host a static website is to use Amazon S3 or Simple Storage Service. So S3 allows you to host files. You can host them both for purposes of backup or DR, or just storage. But you can also use S3 to host a static website. So you create a bucket in S3. You enable that bucket for website hosting. You set your index and error document, and then you're all set. You also have to do a bucket policy to allow global access to that specific bucket. The nice thing about S3 is that S3 is designed for 11 nines of durability. So it's designed to take the loss of at least 2 data centers at the same time without losing your data. S3 also has over 2 trillion objects hosted in it at this point. So it's a very scalable service. And S3 can also, it has a peak request rate of 1.1 million requests a second. So by putting your static website in S3, you do a lot of things. You have a really, by default, very scalable website. You also have something that's very inexpensive because you're only paying for outgoing bandwidth and storage. You're not paying for compute hours. And so S3 is actually a really great option for hosting a static site. Is it possible to use OpsWorks to more like Chef? So yeah, so OpsWorks is just basically managed Chef. So in OpsWorks, you throw in your recipes, and it deploys those recipes in your layers. And so the nice thing about OpsWorks is it means that you don't have to manage your own Chef server. So another question I had here is it possible to modify the Apache configuration file or PHP configuration file in an Elastic Beanstalk PHP instance? Yes, it is. So Elastic Beanstalk has something called EB options, which allows you to tweak what's going on inside of your Elastic Beanstalk instances, so you can use that to modify config files. All right, next question. Okay, so our website is accessed by students around the world. Do you have any best practices that you can share for this scenario? Yeah, so one service that we haven't talked about here yet is uh, Amazon CloudFront. So CloudFront is our content delivery network. CloudFront you can use uh, to deliver both websites, static and dynamic, and also videos, whether they're on demand or live. But in terms of serving traffic around the world, the nice thing about it is there are over 50 edge locations for CloudFront all around the world. So regardless of which region of AWS your application lives in, if you put CloudFront in front of it, CloudFront is going to cache your content, and it's going to serve it with a much lower latency to your users. Now, some other nice features of CloudFront is you can also use CloudFront with SSL certificates, with custom SSL certs, and CloudFront also greatly reduces the actual load you have on your instances. So you can have less instances because they're processing less traffic because that traffic is being cached by the CDN or CloudFront. So there's a lot of advantages to using CloudFront, and it's a really easy way to accelerate your website. We have another question. Are there tools for testing failovers or auto-scaling? So yeah, there are a lot of tools out there. Actually, Netflix has a bunch of really good open source tools. One of them is called Chaos Monkey, and so what Chaos Monkey does is it kills random instances inside your environment, and basically, if your environment can't survive the loss of an instance, then you should definitely architect it to do so. Now, in terms of auto scaling, you can easily just either manually scale up and down to see what happens. You can run a load test, whether you're using a third-party load testing service such as Soasta, or you're just using an open source load testing. application like JMeter or Bees with machine guns, so you can load test your own environment, so you can see what it looks like when it actually scales up and down. In terms of testing the multi-Z failover in RDS, what you can do is you can force a reboot, and that forces a failover. So there's a lot of options out there, and it's actually a really good idea to test your, both your scaling up and down scenarios and your failover to see what that actually looks like before you see it in production. I have another question here. I have a group of developers that needs different types of access to the environment. How can I manage this in AWS? So AWS has something called Identity and Access Management. This allows you to manage access to the AWS Web Console APIs and command line utilities. And so you can create in IAM, you can create users and groups and roles, and you can assign different permissions to the users and groups and roles. So what you should be doing is you should not use the root login that you get when you sign up for a new AWS account. You should just use that to create your first IAM users and then enable two-factor authentication on it and never use it again. So what you should do is you should follow the least privilege principle. So you set up users and you set up permissions for those users that only allow them to do what they actually have to do their job. So if they have to access an S3 bucket, you can write a policy to allow them to access that S3 bucket. If they need to launch instances but only in production, you can write a policy that allows them to launch instances that are only tagged for production. So you can do all kinds of flexible stuff with IAM. And IAM users also support two-factor authentication. You should always use two-factor authentication. That's a best practice. And there's also IAM roles. So what I see happens a lot is people write their code. Their code needs to interact with AWS, with some service on AWS, such as S3. And then that code needs a secret key and an access key to do so, to authenticate with AWS's APIs. Now, what people sometimes do is they'll put the code into their actual application, and they put their application code into, their Git repository or whatever their version control system is, and then they make that Git repository public, and then their credentials have just leaked out onto the internet. So if you have code that's running that talks to AWS APIs that is on the EC2 instances, you should use an IAM role. An IAM role gives that instance inherent access to whatever policy you've bound to that role, so you don't have to store any kind of creds in your code, which is really secure. So I have another question here. Is there any way to get instances that already have the bells and whistles required to host preloaded? So we have an AWS marketplace. On that marketplace, there's all kinds of third-party vendors and tools out there and pre-baked AMIs, both paid and free. So for example, there are pre-baked Drupal AMIs, so you can take something off the marketplace and just launch it and have everything pre-baked for you. So another question here. Can we transfer an AWS setup from one account to another? I.e., if I start an AWS setup, EC2, Beanstalk, EBS S3, with everything affiliated under it, under my personal account, can I then transfer that to a different account? So there's several ways to do that. If at the very beginning you're writing your application as a CloudFormation template, you can just give that CloudFormation template over to another account and have them launch it. They just have to have access to the images that you're launching, which you can do. So you can take images that are custom that are in your account and give another account permissions to those. So you can definitely do that. So the answer is yes. So I have another question here. It says, I have several sites for various departments. Do I need separate instances for each one? No, you don't. So it just depends on how much load each site needs. But there's something specifically, I think it's both in Linux and in Windows, so they're using IS or Apache or Nginx. There's this concept called virtual hosts. So you can set up virtual hosts on your instance, and you can host multiple sites off of that one instance. And then you can have one ELB behind a group of load, or in front of a group of load balancers, and you can have that one ELB host multiple websites. And it'll know which ones to send to which part of the backend based on your host name. Okay, any other questions? Oh, is there any way to get notified? There are messages in SQS instead of constantly checking the queue. I believe that what you can do is probably still have to have a worker that checks the queue all the time right now. I'll have to follow back on that one, but I believe that's still the best practices way to do it. Actually, another way that you can do it is um, if you have your messages go to an SNS topic first, and that for that SNS topic, you can have two different subscribers. So you can have a subscriber that's your SQS queue. So it goes to your SQS queue, and you can have another subscriber that's your email address. So it can email you and put it in the SQS queue at the same time. So that's another way to do it, actually. Okay. Do we have any other questions? All right. Well, thanks for listening, everyone. This is Leo. I'm gonna sign off